Hi everyone, I am Talarnila. My topic is about heart disease classification in fundamentals of data science. Now, this is my raw data for heart disease classification which I have collected from Cahill.com. But the raw data was so clumsy, the data description are not fine and they are very hard to understand. So I am going to change my data description as the following. Now I changed my data description in a well-defined manner which can be easily understood by others. Now these are my data descriptions. Age. The age are represented in years. Sex. 1 is represented as male and 0 is represented as female. Angina. Then blood pressure. Here blood pressures are represented in mg Hg and cholesterol in mg bar dl and fasting blood sugar which is greater than 120 mg bar dl. If the fasting blood sugar is greater than 120, then it is 1 which represented as true. After when the fasting blood sugar is less than 120, then it is represented as 0 which is false. And then ECG, maximum heart rate achieved and exercise induced angina. The angina induced by exercise are represented as 1 which is S. If the angina is not induced by exercise, which is represented as 0 which is no. After that the ST depression induced by exercise. After that the target whether the person is affected by the disease, then it is 1. If the person is not affected by the disease, then it is 0. Angina. Chest pain caused due to blockage of blood vessels. Blood pressure. The normal blood pressure is always less than 120/80 mg/Hg. Cholesterol. The waxy substance present in our blood is known as cholesterol. The high level of cholesterol can increase heart diseases. High level of cholesterol develop fatty deposition in our blood vessels which leads to angina. Fasting blood sugar 99 mg bar dl or lower is normal. When the fasting blood sugar level is 100 to 120 mg bar dl, which causes diabetics. When the fasting glucose is less than 70 mg bar dl, leads to stroke and heart diseases. ECG, which are used to detect certain heart diseases. Maximum heart rate, which is always calculated as 120 minus present age of the person. Exercise induced angina. While doing exercise, heart demands more blood, but the narrow arteries slow down blood flows, which leads to angina. ST depression. The heart rate obtained in ECG due to exercise. Target whether they are affected by the disease or not. Now this is my raw data. There are lots and lots of number of data are available here, but this data are not in a proper order. So it is very difficult to analyze the data for a data use. So I cleaned my data in a simple manner which can be easily understandable. I cleaned my data by using a concept called as vlookup. Vlookup concept are useful in cleaning a data. For example, equal to v lookup bracket the cells to be selected 29 A2 comma the whole table should be selected for that data for the vlookup concept, and then comma the number of rows. For example, now I'm going to take the angina which is in the third row, so 3. After that, if the statement is false, then it becomes as 0. Enter. So and now I got my value. By dragging this, I can obtain all the values in that column. So this is the vlookup concept. Now this is my cleaned data. I'm going to create a pivot table for this cleaned data. I'm going to now select my table and then going to insert option and then to pivot table, and then I'm now selecting pivot table. Now we can give here about the location where the pivot table can be created. Now I have created my pivot table and then my pivot chart. This is my pivot chart. Now I'm going to analyze only the data for angina, and this is my table for my angina, and I'm going to select and I'm going to create my pivot table. This is my pivot table for the angina and my pivot chart. At the age of 45, the angina level and the angina induced by exercise are more. By With help of this pivot chart, we can easily analyze our data. I have collected data for blood pressure. Using this data, I have created my pivot table and pivot chart. At the age of 55, the blood pressure is very high. Then I have taken data for cholesterol and I have created pivot table and pivot chart. At the age of 65, the level of cholesterol is very high. Then I collected my data for the maximum heart rate and created pivot table and then pivot chart according to the ages. Then I have collected ST depression induced by the exercise data and I have created my pivot table and pivot chart for this data. At the age of 63, the ST depression induced by exercise is very high. Then I took data for target, whether the person is affected by the disease or not, and I created my pivot table and pivot chart. With the help of all these data and charts, I have created my dashboard. A dashboard is a visual representation of data that allows you to quick view analysis of our data in one place. In dashboard, we can easily analyze our data. I have created my dashboard with topics and data descriptions. In my dashboard, I have added charts. I created my slicer using pivot. For example, I am taking this as my pivot table and I am selecting my pivot table and I am going for insert option and then to slicer option where we can pick up our slicer. I am adding age and target, then OK. Then I got my slicers. By creating slicers for each pivot table and I added my slicers in my dashboard. Here my slicers are linked with the pivot chart. For example, at age of 29, the level of angina, cholesterol, blood pressure can be viewed in this pivot chart. For blood pressure, the one slicer are available. For example, for 140, at the age of 59, 39, 63, 76 and 152, 45 and 67 and then 138, 136, 152 We can easily analyze our data by the help of slice. Then this is my slicer and pivot chart for the cholesterol. 101 201 cholesterol at the age of 52 and 108 208 at the age of 45, 197 at the age of 53 and 76. This is the slicer for angina. Angina about 1 at the age of 29, 36, 41, 48, 52. At the angina induced due to exercise or at the age of 54. Like this we can easily analyze our data using the slide. This is for maximum heart rate. The maximum heart rate is about 130 at the age of 35 and 71, and 141 at the age of 68, and 132 at the age of 41. And then for ST depression it is 0.1 at the age of 69, 0.7 at the age of 34, 0.8 at the age of 52, 65, 67. Finally, with targets, if I select 0, in these ages the person are not affected by the disease. If 1, in these ages the person are affected by the disease. So using this we can easily conclude about the disease cost. Now this is my dashboard which I have created using all these data and pivot tables and pivot chart slicer. Thank you for watching my video.